Hello everyone. Today in this video I'm going to talk about empirical formula and molecular formula. Empirical formula is the simplest whole number ratio of the atoms or moles of elements in a compound, not ratio of the masses. It can be determined from percent composition. For example, analysis of aspirin gives the following mass percent by composition. There's 60% of carbon, 4.48% of hydrogen, 35.52 of oxygen. Find the empirical formula. I will solve this problem with explaining each steps of how this problem can be solved. We have the composition, which is carbon, hydrogen, and oxygen. We are given the percent composition for these elements. The first thing we need to do is to convert the percent to gram, assuming 100 gram equals 100%. So we assume that we're starting with 100 grams of the compound. So 60% of carbon becomes 60 grams. 4.48 of hydrogen becomes 4.48 grams and 35.52 grams of oxygen respectively. The next thing we do is to convert the grams to mole. We know for carbon, 1 mole of carbon is 12.01 grams. So we convert this to mole with say 60 grams divided by 12.01. Then hydrogen is 4.48 divided by the mass of hydrogen from the periodic table and oxygen respectively. So this gives us for carbon we have 4.996 mole, hydrogen 4.44 moles, and oxygen gives 2.22 moles. So the next thing is we divide by the smallest mole. The smallest mole that we have is 2.22 moles from our oxygen. So we divide everything by 2.2 moles from oxygen. So when we do that, we have for carbon to be 2.25, 2.0, and 1.0 respectively for oxygen. Now, if the result is within 0.1 of the whole number, we round it to whole. However, for the values that we have here, the result is not within 0.1. We have 2.25, so that is far away from 0.1. So we go to the next step, which says if not, we multiply all mole ratio with a number to make all whole number. We multiply all mole ratio. So we have 2.25, whatever we do in order to get whole number, we do for everything. So in this case, I have some factors that we use to multiply. If it is 0.25, we multiply by 4. If it is 0.5, let's say we have 1.5. So we're going to multiply by 2. So if it is 0.75, we multiply all by 4. If it's 0.33 or 0.67, we multiply all by 3. In this case, for our example, we have 0.25 because we have 2.25 here. So we're going to multiply all by 4. So we multiply all by 4. So this is going to be 2.25 times 4, which is going to give us 9. 2.0 times 4 gives us 8. And 1 times 4 gives us 4. We say if everything is whole numbers, so we need to skip. We don't need to go through all this fifth step. So our empirical formula is going to be our carbon is 9 and our hydrogen is 8 and our oxygen is 4. So that gives us the empirical formula for our aspirin. Molecular formula. Molecular formula is a whole number multiple of the empirical formula. To determine molecular formula, we need to know the empirical formula and the molar mass of the compound. These two are very important. So when we know the empirical formula and the molar mass of the compound, the relationship becomes the molecular formula equals to the empirical formula multiplied by n. Then our n, we solve for our n, which gives us this. The molar mass of the molecular formula of Ff, which is always given in the case, so divide by the molar mass of the empirical formula. Let's take an example. The empirical formula for butadiene is C2H3O and the molar mass is 86.09 given. Determine the molecular formula. So again, we're going to write our given. So we know the empirical formula to be C2H30O. And the molar mass is given. Molar mass of the compound is given to be 86.09 gram per mole. So we're going to use our relationship, which is molecular formula equals to empirical formula into n. Our n is going to be the molar mass of the empirical formula, which is given, over the the molar mass of the compound, which is given, and over the empirical formula molar mass. So the molar mass of the compound is already 86.09 gram per mole, and we want to find for the empirical formula. We find for the empirical formula by saying we have two atoms of carbon, which is 2 into 12.01 from periodic table, and 3 atoms of hydrogen, which is these are 1.008 from periodic table, and we have oxygen, which is 15.99 grams. So when we add all this together, it gives us 43.04 gram per mole. So we have that. We plug it into this place. It becomes 43.04 gram per mole. So, and this gives us 2. We now go into our relationship, which is EF. Our EF is C from the question. We say it is C2H3O. Right. And we're using this right now. Our N is 2. Bring it here. So we can use that to open up the parentheses. It becomes C4. 2 times 2 is 4. And 3 times 2 is 6. And this is 1 times 2 is this. So our molecular formula for this compound is C4H6O2. I hope this helps. Thanks for watching.